We've learned about elements that frequently violate the octet rule, including instances when even elements like oxygen and nitrogen can violate the octet rule to form odd electron molecules. So now we have to practice drawing Lewis structures for these kinds of molecules, so that we can understand the bonding behavior of any molecule we might encounter. This won't be too hard if we simply recall which elements are more likely to violate the octet rule, and we try to give an octet to as many atoms in the structure as possible. Take BrCl3 for example. Let's start just like we would with any other structure and draw all the atoms with their valence electrons. Each of these atoms has 7, and bromine is most likely to be the central atom. Now we need to make bonds between the bromine and these chlorine atoms, and we can break up lone pairs to do it if we need to. So let's put 3 of bromine's electrons into bonds to chlorine, which leaves 2 lone pairs left over. Bromine has exceeded its octet, but each chlorine atom has an octet, so this is a favorable structure, as we know that larger atoms with access to more orbitals are more likely to violate the octet rule. This works for polyatomic ions too, like ICl4-. Once again, let's place all the atoms with their valence electrons. Iodine can provide one of its electrons to each bond with chlorine, leaving 1 lone pair and 1 lone electron on iodine once they are all connected. But we notice that there is also a formal negative charge, meaning there is an additional electron somewhere in the structure. The chlorines all have a full octet, but iodine has 1 unpaired electron, so it makes the most sense to place this extra electron on iodine, giving it 4 bonds and 2 lone pairs. Once again, the largest atom has violated the octet rule, and the other atoms have obeyed it. So drawing structures that violate the octet rule is just about knowing which elements are most likely to produce electron-deficient or hypervalent structures, and trying to assign an octet to as many atoms as possible. And now we know how to draw many different Lewis structures.